Well, we are cranking through transports. We did bikes, cars, now we'll do airplanes, and next trucks, as you can expect. Airplanes obviously are getting a lot of attention for their contribution to global warming and carbon emissions. The solution here is listed at number 43 with 5.05 gigatons in reduced CO2 by 2050. The net cost for accomplishing these is at $662.4 billion, but net savings are an impressive $3.19 trillion. This is a nice example of how things are being addressed on multiple fronts. Fuel use is of course one. Easiest is to stop traveling, but you know that that's not possible, and it's not even sure that's the best thing for cultural exchanges, for business, for economy, for employment, and so on and so forth, explorations and so forth. And there are efficiencies in the aircraft design, efficiencies in fuels, and so on. NASA has long been the leading experimenter in future aircraft design. They believe new designs could save airlines $250 billion in coming decades. Along with reducing fuel and pollution by 70%, these prototypes make 50% less noise than conventional passenger planes. That's always a big thing. The aircraft shown here is one of several N+3 design aircraft that can be used 3 generations into the future. So N+3 designs going 3 generations into the future from the present one. Dubbed the double bubble, this MIT model places 3 engines at the rear, as you can see here, of a double wing fuselage, enabling the wings to be smaller and lighter. The rear engine placement allows for smaller engines and reduced weight. And the fuselage itself is like a wing, so accomplishes more passengers and cargo weight. Each optimization on large aircraft has cascading benefits to other components, resulting in ground-breaking efficiency. 70% reduction in fuel and pollution would of course be fantastic. Just briefly, as the book mentions as well, 5 technologies that could help curb airplane emissions from this National Geographic article. Fuels made from cooking oil, sugarcane, biomass, and there are now even talks of solar powered airplanes, and many airlines like United have announced carbon net zero goals for the coming decades, and so on. Engines feature lighter materials, added gears, so basically there is a fan for airflow and there's a turbine for the power generation. If they can be decoupled, then the fan can work more efficiently, enhance airflow, reduce fuel consumption, reduce engine weight, reduce overall weight of the aircraft, and so on. Newer shapes and smaller vertical tail. So vertical tail, you can see this one has this tail here. You know every plane has a vertical tail, so reducing that is another goal. Non-stick coatings could repel bug guts. You think bugs are a small problem. Actually, aircrafts get hit with lots of bugs, and apparently the blood that oozes out forms some chemical reactions and forms coatings that are going to increase the drag and fuel consumption. So some coatings can remove these debris of the bug guts and make the flight smoother and increase fuel efficiency, reduce fuel consumption. 3D printing lightens plane parts. So the way they're manufactured, they're not optimal, precise, and as light as they could be. But 3D printing makes everything so precise that you can actually reduce the material going in. Just looking at some of the data from my favorite site, Our World in Data. This is global CO2 emissions from transport, just to get a sense of where aviation stands. So road passengers are a majority of it, 45.1. Freight trucks at 29.4 includes trucks and lorries. Aviation, 81% passengers, 19% from freight. So passenger planes carry about half the cargo, and cargo planes carry, dedicated cargo planes carry the other half. So that stands at 11.6%, and we talked about shipping at 10.6%, rail and other are lower than that. So this is what we are aiming at. Per capita CO2 emission from international flights, tourism adjusted. So you can take total flights into and out of a country, but you can then attribute only the non-touristic miles to the native population. So you can see that there are some countries maybe more remote, so Canada and Australia, but there are some up here which Scandinavian and UK also have fairly high per capita CO2 emissions. Reasons have to be figured out, and there is this little Oman, I think, which is maybe rich and touristic, but this is tourist adjusted, so I'm not completely sure why they have high footprint. Per capita CO2 emissions from international aviation, if you don't adjust for tourism, then obviously you get higher emissions. You can see here US is in the range of 100 to 250 here, whereas here Italy is in the range of 250 to 500. So these countries still remain large emitters overall. Per capita CO2 emissions from domestic aviation, here US is and Australia are large, but the countries like China and India are growing rapidly as well. So in general you can see richer countries have more domestic flights, but even economically growing countries are beginning to grow tremendously in domestic air travel. Global airline traffic and aviation efficiency. So this is revenue passenger kilometer RPK that we talked about before, which measures the number of paying customers multiplied by the distance traveled. Available seat kilometers, ASK, measures the total number of seats available. Ratio between RPK and ASK measures the passenger load factor, so if all the available seats were used or not. Aviation efficiency data does not include non-CO2 climate forcing or a multiplier for warming effects at altitude. So depending on where you emit, you can have a different impact. So this is ASK, this is RPK, these are CO2 emissions per revenue passenger, and you can see over time the aviation efficiency in terms of kilograms of CO2 per RPK increased around 20-fold since 1950 and 11-fold since 1960. So the aviation has become much more efficient. 20-fold since 1950 and 11-fold since 1960. So that's a massive increase. In 2018, 0.125 kilograms CO2 was emitted per revenue passenger kilometer. So that's good news, right? We are flying but much more efficiently. We are flying more but much more efficiently. Global carbon dioxide emissions from aviation. You can see here in 2018, 1.04 billion tons, 4 to 5% growth per year since 2010, doubled since 1987, and so on and so forth. Aviation as share of global CO2 emissions has also kind of had a little up and down, probably related to finance, economics, business travels, slowdowns, etc., etc. Okay, so of course weather plays a big role in fuel efficiency. This is showing a bumpy takeoff, which is to be avoided to reduce fuel use and of course passenger and aircraft safety. But the behavioral aspects are being tried apparently on pilots by giving them indications of their fuel use and targets for them to reduce fuel use. Then they become mentally better at avoiding these kinds of situations and reducing overall fuel consumption. This analysis focuses on adoption of the latest and most fuel efficient aircraft, retrofitting existing aircraft with winglets, newer engines and lighter interiors, and retiring older aircraft early. Over 30 years, 5.1 gigatons of carbon dioxide emissions can be avoided, saving $3.2 trillion on jet fuel and operating costs. Other efficiency measures could provide additional emissions reductions and savings. So seat weight, seat placing, leg space, everything is being considered in terms of their impact on fuel efficiency and emissions reductions.